In this portion of the videos, we are trying to learn how to draw our own electron-pushing arrows. And so it's important to know what are the rules you have to follow to draw a legal electron-pushing arrow. So we're reviewing the various rules for when your electron-pushing arrows are legal. We've gone over a bunch of rules, but now we're talking about really by far the most important rule. This is the rule that's most likely to lead to mistakes and give students the most trouble. This is the rule for how to avoid exceeding an octet. Now remember that anytime you form a pi bond, there's a potential that you might accidentally exceed an octet. When you form a pi bond, there's the potential that you might accidentally exceed an octet. So what do you need to do to make sure that that new pi bond does not exceed an octet? Well, the new pi bond has to be formed with a carbocation. That's one possibility. Clearly a carbocation started with too few electrons. You don't need to worry that the carbocation is going to exceed its octet because it was starting with too few electrons, so it can afford to gain a pi bond. So one good way to form a new pi bond is to form it with a carbocation. And there's another major thing that we could do. You could form the new pi bond with an atom that's losing a pi bond. That's the other major way to make sure that you're not exceeding the octet rule. So if you're forming a new pi bond, and you're not doing it with a carbocation, then the atom that's gaining the pi bond on one side had better be losing a pi bond on the other side. If we are forming a new pi bond, we can do it with a carbocation. But if we're not forming a new pi bond with a carbocation, the atom that is gaining that new pi bond had better also be losing a pi bond, because otherwise it's going to have exceeded its octet. The only way to prevent itself from exceeding the octet is to balance the electrons that it's gained from the new pi bond with the electrons that it's lost from the pi bond that it's losing. There is one more way that you could form a new pi bond. Maybe I'll briefly mention that now. Remember that we've already seen that it's okay for an atom in the third period or below to exceed an octet. So it's okay to form a new pi bond with an atom that's in the third period or below, even if it doesn't satisfy these two criteria. Even if an atom in the third period or below, like say sulfur or chlorine, even if that atom does not satisfy these two criteria, it's still okay for it to form a new pi bond. It might end up exceeding an octet, but we know actually it's okay for atoms in the third period and below to exceed an octet. I'm not going to write that on the board right now because that plays a much less important role in organic chemistry. It's important enough to be worth mentioning, but these are much more important. So that's what I want to focus on right now. So if we ignore that exception of the atoms in the third period and below exceeding their octet, this is what you're generally going to focus on. If you form a new pi bond, you have to do it with a carbocation or with an atom that's also losing a pi bond. This is the way we can make sure that when we make either of these transitions, we're not exceeding the octet rule. So notice that these are things we have to watch out for in either of these transitions. If we're taking a pi bond and making a new pi bond, or if we're taking a lone pair and making a new pi bond. In either case, we have to satisfy one of these two criteria. On the other hand, we've seen that we never have to worry about exceeding an octet for this transition. We've shown you some examples so that we could see that when you take a pi bond and make it into a lone pair, it's impossible for that to exceed an octet. So we don't need to worry about this exceeding the octet rule. So I hope you can see that on the blackboard I've tried to indicate with these braces that these criteria only matter for these two transitions. They only matter when you're forming a new pi bond. A new pi bond must be formed in these ways. Maybe this is a good way to put it then. Any new pi bond must be formed with a carbocation or with an atom that's losing a pi bond. Or, even though I didn't write it on the board, or with an atom that's in the third period or below. But we won't focus on that as much. These are the major ways to form a new pi bond. On the other hand, it's much easier to form a lone pair. You can pretty much form a lone pair kind of any place that you want. At least you don't need to worry about exceeding the octet rule. Okay, well I really want to emphasize this because this is the source of by far the most problems and the most mistakes when people are drawing resonance forms. So the thing we have to drill into ourselves is now we have to be on the watch anytime we form a new pi bond. We have to be very careful anytime we form a new pi bond and make sure it's satisfying one of these two criteria. We don't need to be as careful when we form a new lone pair.